now we will see derivation of centroid of semicircle of radius r. We will derive the centroid for semicircle of radius r. So I'll write the diagram. So for the derivation of the centroid of semicircle, let us draw the semicircle first. So this is not a semicircle, it become a segment. Okay, so I written a different diagram, semicircle. So we let the radius of the semicircle be r and the diameter be AB. Okay, so diameter is 2r, then diameter length will be 2r, the radius is r. So after writing this semicircle, we will, as we considered an elemental strip in the triangle, we have to consider again another elemental strip in this, so that we can find the centroid. So I'll take an elemental strip. Okay, so this is OMN. Let this OMN be the elemental strip at an angle theta, making angle d theta. Okay, so when you see this elemental strip OMN, what is it? So it feels like it is an triangle. So let us, if this is a triangle, so for triangle we already know where the centroid lies. So from base it 1/3, from apex it is 2/3 h. So before that we will write up what we have written till now. That is, the figure shows a semicircle of radius r. So what we consider a elemental strip or elemental area OMN at an angle theta. So at an angle theta, making an angle, and it will make an angle d theta. So what I explained in the diagram, I write it in the wordings. So it is also important, it can also be asked. Okay, so now we can see that this elemental area OMN, so it feels like it is an triangle, right? So it is similar to the triangle. Therefore what I do is I'll take the area. So what I want, finally I want sigma AY by sigma A. Now I think so. We have to come at this situation, either it is X or Y. So I'll take first the area of, I'll consider this as a triangle. Okay, because it is elemental strip is so small. Here we enlarged it, but it is so small that this curvature will not be taken into consideration. So ಎಷ್ಟು ಸ್ಮಾಲ್ ಇರುತ್ತಂದ್ರೆ ಈ ಕರ್ವೇಚರ್ ನಮಗೆ ಇದೆ ಅಂತ ಗೊತ್ತಾಗಲ್ಲ, ಇಟ್ ವಿಲ್ ಬಿ ಸ್ಟ್ರೇಟ್ ಓನ್ಲಿ. ಹಿಯರ್ ನಿಮಗೆ ಅರ್ಥ ಆಗಲಿಕ್ಕೆ ಅಂತೇಳಿ ದೊಡ್ಡದಾಗಿ ಬರಿತೀವಿ. ಸೊ ಏರಿಯಾ ಆಫ್ ಟ್ರಯಾಂಗಲ್ OMN. So because it resembles like a triangle, I'll apply the triangle formula, half into base MN into what is the height, that is O into M. Okay, height will be a point like this, but we'll take as OM only, nearer to that. So what will that, half into what is this MN? So MN can be written as, see here, so this is the triangle OMN, right? I'll write this OM is nothing but the radius of the circle, R into MN. So now I have to find MN. So any arc is drawn with a radius. So how do you find this? From the basics. Okay, just remember here when you come across this type of problems. Okay, so a center is there with a radius, and here is one arc. If it makes an angle theta, okay, or if makes an angle theta, then this is r, then the distance will be of this arc will be r into theta. So this distance l, so l is equal to r into theta. If an arc is subtended by angle theta, radius r, the length of the arc will be r into theta. Same rule here. The angle is d theta, radius is r, so this mn is equal to r into d theta, the length of arc. So I wrote OM as this, so mn r into d theta. Therefore it will be half into r square into d theta. What is this? Area of triangle OMN, half into r square into d theta. So once we get the area, what we will do, we will assume now, let C, okay, let C be the centroid. Once we get the area, we will place or we will consider C as the centroid of the elemental area, as the elemental area is what? Triangle. C center of the elemental area acting at a distance of, this distance we know, because for any triangle it will be h by 3 or 2h by 3, like that. So distance of OC. Okay, that I'll consider C. Consider C as the center of the elemental area acting at a distance of OC. Okay, so that OC means it is from the apex, right? So it is what? 2 by 3 h. H is nothing but here radius. 2 by 3 r from origin O. So now this is C, OC. So this is the centroid. It is at a distance of 2 by 3 into r. Okay, now I'll just drop a perpendicular here towards this axis, AB axis, and I'll just take a perpendicular to this O axis. So I'll name this, let it be ABC, this be D, and this be E. Okay, now I'll find the distance of CE and CD. So now the distance of CD, so I want distance of CD, this CD, and also CE. So before I am getting the distance, I'll take this triangle now. See here, if imagine or imaginary line OC, so this OCD will form an triangle. So the same OCD I will write here, CO. So this is OCD. This is centroid. This is the drop perpendicular with reference to the bottom axis, right? Now this is the OCD, and we don't know this also. Okay, fine, no problem. Now I want CD, this distance I want. Okay, I want this distance. So I know this triangle. How can I find now? So CD is what? Opposite. So it is an opposite angle. So theta is equal to what? Sine, that is sine theta is equal to CD, opposite by hypotenuse is OC. So I want CD. Okay, CD is equal to OC sin theta. Can I write OC sin theta? Yes, we can write as OC sin theta. And I also want, with the same concept, similarly, what I want, CE, right? This one, CE, see here, this triangle, this one, with the same concept. If I similarly for OCE triangle, I'll write directly, that is CE is equal to OD, or you can take this CE is also perpendicular to OD. I can write OD. OD is equal to nothing but this OD, as well as this is sin theta, same will be as cos theta, that is OC cos theta. See, you have to remember, this is the key for this semicircular centroid, derivation of semicircle or centroid. So this EC is same as distance OD. So from this triangle, I'll take this and I want this. So CD I wrote as OC sin theta. Similarly, CE, or that is equal to OD, is equal to OC cos theta. So I'll write the same now. CD is what? OC sin theta. Okay, and CE is what? C is OC cos theta. Okay, so now what happens? This CD is equal to, what is OC? OC is nothing but the distance of OC is nothing but the 2 by 3 R. Okay, that is 2 by 3 into R sin theta. CE is equal to 2 by 3 into R cos theta. So I got both CD and CE. Okay, now what I do, see, so I founded CD and CE by the help of elemental strip. Now, so height of CG, now I'll take height of CG above OB, that is equal to what? The distance CD, and that is the distance we are finding for sigma AY by sigma A from the formula. What I did, I just calculated. So I'll again explain you. The figure shows a semicircle of radius R. I considered an elemental strip OMN. So and I calculated the area of this triangle. Considering a triangle, I'll consider this triangle. I found the area. This is area of triangle is equal to half into R square into d theta. So once I assume that as a triangle, I'll consider for this elemental strip C is the centroid. Okay, when I consider C as the centroid, from where, from base or apex, I consider from apex it is 2 by 3 R. At a distance of 2 by 3 R, I consider C as a centroid of this elemental strip. So this elemental strip is what? This is a part of this semicircle. So many elemental strip will be there, so many triangles will be there, so many centroid will be there. So in that one we will considering here. Now let C be the centroid of the elemental area from 2 by 3 R. Okay, so now so many elemental strips will be there, but for this elemental strip which we consider, I want the distance of CD and CE. So for this CD and CE, what I did, I considered this triangle. By considering this triangle, I got an equation, that is CD is equal to 2 by 3 R into sin theta, CE is equal to 2 by 3 R cos theta. This CD is nothing but what? This is the Y bar. Okay, and this is nothing but the X bar. Okay, when we, for this elemental strip, but when we consider, or when we take this elemental strip, when we integrate this elemental strip from the 0 to B, or I'll tell you now what is the integration limit, that is for semicircle it is so 0, right? so it is 180. So half means for full circle, see here, for full circle it is 360 degree, and for semicircle it is 0 to pi. ಓಕೆ, ಒಂದು ಎಲಿಮೆಂಟಲ್ ಸ್ಟ್ರಿಪ್ಪಿಗೆ ಕಂಡು ಹಿಡಿದ್ವಿ. ಸೊ ಇದೇ ಎಲಿಮೆಂಟಲ್ ಸ್ಟ್ರಿಪ್ದು ನಾವೇನು ಮಾಡಿದ್ವಿ, ಸಿ ಡಿ ಕಂಡು ಹಿಡಿದ್ಬಿಟ್ಟು ಈಗ ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ದಿಸ್ ಸಿ ಡಿ ಐ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್. ಈ ಫೈಂಡ್ ಮಾಡಿಕೊಂಡು ಇದನ್ನು ನಾನೇನಾದರೂ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದರೆ, ಇಂಟಿಗ್ರೇಟ್ ಫ್ರಮ್ ದ ಲಿಮಿಟ್ ಈಸ್ 0 to pi ವರೆಗೂ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದರೆ ನನಗೆ 0 to pi ಏನಾಗುತ್ತೆ, ಸೆಮಿ ಸರ್ಕಲ್ ಆಗುತ್ತೆ. ಸೊ ಇಫ್ ಐ ಕನ್ಸಿಡರ್ ಹಿಯರ್ 0, so this elemental strip full will cover up to pi. So when I integrate from 0 to pi, I will get the centroid of the full semicircle. This is the concept here. So I calculated C and C. Now height of the CG above OB, that is nothing but the CD. What is that CD? That is CD is nothing but the y bar is equal to sigma ay by summation of A. So now I have to solve for summation of ay divided by summation of A. So what is the area of the OMN? We got area of the triangle OMN. What we got? Half into r square into d theta. Y is the distance, but y is nothing but the distance, that is CD, that is what, 2 by 3 r sin theta. Okay, so we are integrating for the height of CG above OB for the whole semicircle, for the whole semicircle, or I'll write, okay, semicircle. For the whole semicircle, what I'll do, I'll integrate from 0 to pi. So this is the integrate for the semicircle 0 to pi. What will happen? Summation of ay. What is the area? Area is half into r square into d theta into what is y? Y is nothing but CD. CD is nothing but 2 by 3 r sin theta divided by what? Half into r square d theta. So many elemental strips will be there. We are considering only one to gain the answer. So now simplify it. So what it happens? So I'll take 0 to pi and I'll 1 2 cancels. So I'll take this r cube. So theta is the function, right? So r is the constant. So r by 3. So this r and this r, what will it become? It will become r cube. So okay, you here don't cancel all the things, you just keep r into r is r cube, then d theta, that is sin theta into d theta divided by, okay, here also half you r square into d theta, r square by 2, you take common 0 to pi. Okay, I am integrating separately, which is also a rule in the integration, if you remember. So half into r square, I take 2, I took, so it is d theta. Then what happens? This r cube by 3 and this r square by 2, I can cancel it. So when cancelling, it will be 2 by 3. So 2 by 3, one r will remain into this sin theta. Integration of sin theta is cos theta, but it is negative. So 0 to pi is the integral divided by 0 to pi of d theta. So integration of d theta is theta 0 to pi. So in the value of 0, if you put, we will get 0 only. So we will see first. So 2 by 3 into r minus cos pi plus cos 0 divided by pi minus 0. Okay, now what happens? This y bar this y bar is equal to, so cos pi you know, so what it becomes negative. Okay, so minus cos phi minus of minus cos 0. So what it, cos pi is what, minus 1, this is also minus 1, so it become 2. So 2 by 3 r into minus 2 divided by pi. So y bar is equal to 2 to the 4r by 3 pi. So this can be solved by, here again I'll tell you, so minus cos pi plus cos 0, so minus into minus it will become plus, sorry I was confused, so cos 0 it will happen. So in the all students take coffee, so here all the signs are positive. Here in the second quadrant sine and cosine are positive, here tan secant, okay, sine cosine are positive, here tan is positive, here cosecant theta is positive. Now so this what it becomes, so cos of minus 5 plus cos 0, so cos of minus anything it will be cos 5 only plus cos 0, so it is 1 plus 1, it will be 2. Okay, 4r by 3 pi. Okay, so when I integrate with this integral I'll tell you again. See here, so minus cos theta 0 to pi, so minus cos pi minus, but here again minus is there, minus into minus plus cos 0 will happen, so minus cos phi is nothing but the cos phi plus cos 0, so cos 0 is 1, cos phi is also 1, so 1 plus 1 is 2, so 2r by 4r by 3 pi. So it is from the, okay, 4r by 3 pi you can write, or also 4 divided by 3 is how much, 0.42, 0.424 into r from diameter. Okay, you remember this, you up to this you have to do y is equal to 4r by 3 pi. So now the concluding statement is, the centroid of semicircle is y bar is equal to 4r by 3 pi from its diameter. You can also calculate by 4r by 3 pi is nothing but the 4 divided by 3 pi is 0.424 into r from diameter. So this is how we find the centroid of the semicircle. Next we will see the centroid of a sector of a circle. So before going to the sector, we'll also learn about the center of the quarter circle. So this is the quarter circle, that is one of the quarter part of the circle. So I'll take as O as center and A, so this is the reference, AB as the arc. So as same, the same procedure is same as for the semicircle which we have done now. So what we have to do, we have to consider an elemental strip OMN. So OMN, so to maintain uniformity I'll take the same notation. So this OMN, we elemental strip, elemental area, what it make, it will make an angle theta, making an angle d theta. And we also consider a centroid. Okay, it is also at a distance of 2 by 3 r, same as we did in the semicircle, no, but what we do here, here the limit will change during integration, that is 0 to pi by 2. So what is this, 90 degrees, 0 to 90 degrees pi by 2. So I'll go quickly in this topic. So the figure shows a quarter circle of radius r. Okay, this is the radius of r. So as we consider in the semicircle, so consider an elemental area. What is that elemental area? OMN, making an angle theta, making an angle d theta at an angle theta from bottom reference axis. Okay, so same procedure as we did. So what we did, we founded the area of triangle OMN. What we got, so half into MN into OM. So for procedure you can see again that semicircle, so half into r into d theta, it was about half into r square into d theta. Okay, so after that what we did, let C be the centroid at a distance of, that is OC. So C is the distance, so we have to find what, this D and this E. OC, that is equal to 2 by 3 R from apex, same what we did in the semicircle. So what we got, CD is equal to what, OC sin theta, CE is equal to OC cos theta. This is nothing but 2 by 3 R sin theta, 2 by 3 R cos theta. So this was about the elemental strip. Now what we will do, we will just find the height of center of gravity. Okay, height of center of gravity above diameter OB. Okay, above the reference axis content or above OB. Okay, now we have to find this one, that is nothing but the, this OB nothing but CD is nothing but y bar, that is summation of A into y divided by summation of A. So we know the area, that is half into r square into d theta, and y is 2 by 3 r sin theta. So y is what, this CD is what, OC sin theta, that is 2 by r sin theta divided by half into r square into d theta. Sorry, let's see, half into r square into d theta. Now we want about the full quarter circle. So for full quarter circle, what we have to apply, we have to integrate from 0 to pi. So after integrating, what we will get, 0 to pi by 2 till up to 90. So I'll take here only, that is 2 get cancels, or I'll keep them. No, see here, this r cube, I'll take r cube by 3 into sin theta into d theta divided by half into or r square into d theta. Okay, now so this r cube by 3 divided by r square by 2 will come outside. Now integration of sin theta into d theta, what is that? That is nothing but the cos theta, right? Cos theta, that is 0 to pi by 2 divided by theta is 0 to pi by 2. So now this is nothing but 2 by 3 r, what it happens, minus cos pi by 2 minus cos 0 by 2 is nothing but the 0 only, divided by theta is what, so pi by 2 minus 0. Okay, after simplification what I'll get as, so in the first quadrant all sine, tan, cos are positive, all are positive, right? All students take coffee. Here sine and cosine are positive, tan and secant, cosine and, all students take coffee, this you remember. All is what, sine, cos, tan are positive. Here sine and cos are positive, here tan and cot are positive, cosecant and secant are positive, other angles are negative. So 2 by 3 into r, so it is in the 0 to 90 degree only, it is in the first quadrant, so the first quadrant value will be 0 to pi by 2 only, so it will be cos pi by 2 plus cos 0 is 1 divided by pi by 2 minus 0, so cos pi by 2 is what, 0, so 2 by 3 r into 1 divided by pi by 2, so when it goes upwards it will become 2 into 2 4r by 3 pi. Okay, it will go upward, it will become 4r by 3 pi. So the y bar for the quarter circle is also same, 4r by 3 pi. The centroid for the quarter circle will be same as 4r by 3 pi. Similarly we can show, similarly for y bar is 4r by 3 pi, for x bar it would be 4r by 3 pi only. Okay, so now we can tell that the distance of the centroid, the distance, so the distance of the centroid G of the quarter circle from its diameter, will be x bar is equal to y bar, which is equal to 4r by 3 pi. Remember this, both x and y bar will be 4r by 3 pi, so it will helpful in our problem. Okay, same, nothing is changed, all the procedure is same except the integration. So here this is the key point. So now I'll go for the sector of the circle. Now let us see the centroid of a sector of a circle. So I'll write the figure, I have written the comment before only. Okay, so what I am making, I am drawing a sector of a circle by making x-axis as symmetrical. Okay, so what I do, see here, so this is the sector of a circle with the radius r, this is O and this is y-axis. So this is also alpha, this is also alpha, it's making an angle of 2 alpha of radius r and is symmetrical about x-axis because it is symmetry. So here symmetry comes into the picture. Okay, because of the symmetry, what happens means, if centroid is formed here, because of the symmetry only, this y bar is equal to 0. So if any plane, in any plane, if symmetrical axis is there, if the mirror copy is equally divided in them, then the distance respected to that axis. If the centroid is here, the distance respected to that axis will be 0. So if here centroid is here, the y bar will be 0, like that. Okay, just consider this. Now we have to, here the key point is we have to understand that we have taken the sector of a circle symmetrical about x axis, so that y bar is 0. And also we will consider, now same as we did in the last problem, consider a triangular area, that is OMN. Okay, so triangular area, it will be so many triangular area, but to visualize we are taking big one, that's it. So let this be OMN. Okay, this triangular area makes an angle, and triangular area OMN makes an angle theta at x-axis, making an angle d theta. Okay, it will make an angle d theta inside, theta is this one. So okay, same as we did in the last two derivation. Okay, because we have inserted an elemental area, what we will do, we will take the area of triangle OMN, what we have got, half into r square into d theta. You have to write fully. I am taking here directly. You have to write OM into MN into, like that, which we did in the previous derivation, like that you have to do. So then what we consider, let C be the centroid of the plane lamina at a distance of 2/3 into r, that is what, OC. Let we will discover C. So here this distance will be nil, but we have taken it in enlarged view, so this distance is coming. But here when we find the centroid of a sector of a circle, when we find the centroid for sector of a circle, keep in mind we have taken x as symmetrical, so we shouldn't find because y bar is already 0. We should solve for x bar. So I'll tell you. So let's see the centroid, and its distance be 2/3 r sin theta. So again, as we did in the last two derivation, that is CD, but we will consider now. Okay, this will be E, this be E. Okay, so CD is equal to what? CD is 2/3 sin theta, and CE will be 2/3 cos theta. Now what we'll take, we know that the horizontal distance of centroid from, we know that the horizontal distance, so we are not taking height here, we are taking the horizontal distance, means which comes in the x-axis of centroid, horizontal distance of centroid from y-axis. Very important, this is also a key point to remember. The sector of a circle, we have to know the horizontal distance of centroid from y-axis. From y-axis, what is the distance we are getting? We are getting x bar is equal to sigma ax divided by sigma a, summation of a. Now we have to solve for x bar. So x bar is equal to, for full sector, okay, what is the, what we have to do, we have to integrate. So before integrating, see here what we have to do, we have to take this alpha and this alpha both, so minus alpha to plus alpha, That's why we are taking this symmetrical axis to solve the centroid of a sector easily. That is x bar is equal to, that is minus alpha 2 plus alpha. What is the area? We know that half into r square into d theta, and again is 2 by 3 r cos theta. Here will, there is also key point, it will change us. Here we are taking CE 2 by 3 r cos theta and half r square into d theta. Okay, here CE, we are taking this distance. This distance is nothing but the sigma a into x. So as usual, after solving, what we are getting, so minus alpha 2 plus alpha, here we are getting r cube by 3, then this is nothing but cos theta into d theta. So here also this is r square by 2, so minus alpha 2 plus alpha, what we are getting, d theta. So if we integrate, what we will get, so r square 2 by 3, so 2 by 3 r. So if we integrate cos theta, we will get sin theta, that is minus alpha 2 plus alpha divided by theta minus alpha 2 plus alpha. Okay, now this only I will do 2 by 3 r. So now sin theta, I will first sin alpha minus alpha, so minus of minus plus, it will become sin alpha divided by alpha into minus of theta ಜಾಗದಲ್ಲಿ ಮತ್ತೆ minus alpha plus alpha ಆಗುತ್ತೆ. Okay, now so 2 by 3 r, it will become what, sin alpha plus sin alpha. 2 by 3 r 2 sin alpha divided by 2 alpha. Okay, alpha into alpha, so this two will cancels. So what it implies, 2 by 3 r into sin alpha by alpha. So x bar, we can tell that x bar is nothing but 2 by 3 r into sin alpha by alpha. Remember the value of x bar. So this is the distance of centroid from y axis for the sector of circle. So these were the three derivations: semicircle, quarter circle, and sector of a circle. So by this method, we can find the various centroidal distance of the centroid for sector, quarter circle, and also for semicircle. Now what we will do means, we will just remember the formulas. So I have collected some of the formulas here. See, so shape is rectangle, so I'll attach this formula list to the link. Okay, it will be downwards, you can download that. So shape is rectangle, area is b into d. So what is the centroid distance? This is x bar distance, this is y bar distance, that is b by 2 d by 2. Figure is like this. So when we come to triangle, half into b into d, so x bar is b by 2, y bar is d by 3. This is the triangle of distance d. So x bar is what, b by 2, d is d by 3. Okay, now if it is right angle triangle, so these are formulas we require when we do the problem. If we remember this, we can solve the problem easily and very quickly. So right angle triangle, half into b into d, So this is the y distance and this is the x distance. X bar is b by 3, it is d by 3 for circle. So area is pi r square. X bar and y bar are equal to r. For semicircle, see here, so area is pi r square by 2. If the semicircle lies in the first quadrant, then the distance of the centroid, the x distance will be d by 2 and the y distance will be 4r by 3 pi. This we calculated. If it is in the fourth quadrant, what happens? The distance will be same, d by 2, but the y distance will be minus 4r by 3 pi because it is going negative. X, it is below the x axis. So here x is positive but y is negative. So y is negative 4r by 3 pi. If it is here like this, then also x will become 4r by 3 pi, d will become d by 2, y will become d by 2. So if you remember this formula by seeing the image, you can directly solve the problems. Okay, next one is, see here, if it is in like this, x will be minus 4r by 3 pi, d by 2. So quarter circle, pi r square by 4 is the area. So x will be 4r by 3 pi, y will be 4r by 3 pi. This is the diagram. So this was about the derivation of centroid of semicircle and quarter circle and also the sector of circle. From next class we will go to the problems. So we have number of types of problems. After problems we will go to the moment of inertia and then we'll continue our classes. Thank you.